In this video, we're going to take a look at Practice Quiz 12, focusing on solving and graphing rationals. So number 1 says, solve the following rational equation. So I see that I have a fraction on either side of the equal sign. So in these, I'm able to just cross multiply. So I'm going to take 2 and multiply it by x plus 3. But since that's more than one term, I'm going to put those in parentheses so I remember to distribute the 2. And then I have 4 times the 7x. So then I'm going to distribute the 2 like I mentioned and get 2x plus 6. And then 4 times 7x would give me 28x. Then I'm just going to solve for x the way we normally would. So I'm going to subtract 2x since it's smaller and get 6 equals 26x. And then we just need to divide both sides by 26. And then we can just reduce that to be, they both divide evenly by 2. So that'd be 3 over 13 for our x value. Now, if we would like to check that answer, we can check it with Desmos by typing it in and checking the x-intercept. So if I just type the original problem, I'm just looking for the x-intercept to see if it looks like what I got for my answer. So let me type in the original problem. Then I also have a fraction, so I'm going to get a decimal for that, which would be 0.23. So you can tell from your x-intercept, it does look like it's about in the right spot for that. If you really want to click on it, I think you can move everything to one side, and then that allows you to click on it. So I just subtracted the one fraction to the other side is all I did to do that. And then I'm able to click on it and make sure it does give me the exact same thing so I can be certain I got the right answer. And the other thing you could do is type them separately so it turns it into a system of equations. So if I have the first one in one row and then the other side of the equation, so like the left is in one row and the right is in the other row, then where they touch is also another way you could check your solution. But either way, I know I've got the right answer. So let's go on to number 2. And I'm going to move Desmos out of the way for a minute. It says solve the following rational equation. So this one has multiple fractions that I can't just easily combine. So I'm going to work to make all of the denominators become 6x squared because I see that I can do that without too much work. And we always want to try to do the least amount of work. And I need to make that last one be 6x squared. So in the first fraction, I already had 6x squared for the denominator, so I just need to bring down the one that was already the numerator. For the second fraction, I have 2x, so I need to multiply it by 3x, because that's what will help me get my new denominator of 6x squared. So whatever I do to the denominator, I have to also do to the numerator. So 3x times 1 is 3x. And for the last one, I just have to multiply that one by 2 to help me get my new denominator of 6x squared. So then 7 times 2 in the numerator would be 14. And once you get all of your denominators to be exactly the same, you can cancel them out and bring down the numerators and solve what's left. So I have 1 equals 3x plus 14. I can subtract the 14 and get negative 13 equals 3x. And then when I divide both sides by 3, I get x equals negative 13 over 3. And again, we can check that with Desmos. So something you might want to do is just put what is on the left in one row. So let's try it this way. So we'll be able to click on it since we have kind of an odd number again. So I'm going to type in 1 divided by 6x squared in one row of Desmos. And then I'm going to type everything on the right side just in a different row. And that creates a system of equations from your one equation, which you can always do to check your answers when you're solving equations. So then I'm just looking for where they touch. So don't mind how it looks. You're just trying to find where they touch. And I know it's a negative solution that I got. Let's see, negative 13 divided by 3 would give me negative 4.3 repeating. And when I go over there to that number, they do touch right there at negative 4.3. All right. So then that is my solution. And I would just leave it as a fraction. Unless you have a reason to make a decimal, it'd be more accurate. So number 3, Mary can paint a certain room in 4 hours, but Kendra needs 5 hours to paint the same room. How long does it take them to paint the room if they work together? So Mary can paint the room in 4 hours. So you want to set up Mary's equation as one room in 4 hours. So 1 over 4. Kendra needs 5 hours, so we're going to add Kendra's time. So it's still one room, so that's why your numerator is 1, or one job is what we call it, over 5, because she takes 5 hours. And then we want to know how long would it take them to work together, so that's why we add them. And then we set it equal to 1 over x, since we don't know how long it'll take them to work together. So then I'm just going to get a common denominator. So I'm going to multiply the first fraction by 5 and the second fraction by 4. And that way I get a common denominator of 20. So I get 5 over 20 plus 4 over 20 equals 1 over x. And then I have 5 plus 4 would give me 9. So then 9 over 20 would give me 1 over x. And then I can cross multiply to finish solving for x. So I have 9 times x would be 9x, and then 20 times 1 is 20. And then my last step, I just need to divide by 9. And then we get 20 over 9, which would be, let's see, what would that decimal be? And we need to usually convert it into hours and minutes, because that would make more sense with this problem. So I see that I have 2.2 repeating. So that means it takes 2 hours, but then do 0.2 repeating, so carry it out a little ways to show that it's repeating in your calculator, times 60 minutes. So it'd be about 2 hours and 13 minutes is what we found. And you don't have to worry about the seconds. Usually they just do hours and minutes in that case. Okay, so I'm just going to scoot it up there. And that is it for number 3. So that would be our best answer. And if you put it as a decimal and leave it that way, it's okay. I just want you to practice trying to convert it to hours and minutes, since that's what you'll most likely see on a question. Okay, number 4 says the junior class is planning prom for this year. The venue costs $1,200 to rent, and there's an additional cost of $20 per person for food. Write a function to model the average cost per person at prom. All right, so we're going to write f of x or y equals, either one is fine. The venue costs $1,200 to rent. So we'll put $1,200. And there's an additional cost of $20 per person. So we'll add 20x, but we want to know the average cost per person. So we got to divide by the total number of people. So then we know x is number of people. And then f of x would be the average cost per person, because that's what we're trying to find out. That would be our output. Let me just scoot that over a little. Okay, so it says, where is the vertical asymptote of this function and what does it represent in this problem? You can graph it and look at it, or you can just use your rules for vertical asymptote and horizontal asymptote, because that's our next question. And the vertical asymptote always comes from where your denominator would equal 0, is how you can look at it and pick it out, because it's restricted. Those are the restricted values just from our denominator that are not holes in the graph. So I see I have x in my denominator, and it would be where x equals 0, since that's all that's in the denominator. So you want to think of what would that represent. So x, I can go back up here and say x is my number of people. So it would be as the number of people approaches 0. That's what that represents. So let's put some words here. The vertical asymptote represents that the function is undefined where the number of people would equal 0, because you wouldn't have a prom at that point, so it wouldn't make sense. So that is our context. So it's never going to equal 0, like I say, or you don't really have a prom at all. So that is what it's approaching if we're looking at the vertical asymptote. And let me finish it with just all words. Okay, so the vertical asymptote represents that the function is undefined where the number of people would equal 0, because your vertical asymptote is at x equals 0, and x is our number of people. And so that would make sense that it would be undefined, like I said, because then you don't really have a prom. Now the horizontal asymptote, we can either look at our graph to verify it, or we can just use our rules of picking it out. So I notice the degree in the numerator is 1, and the degree in the denominator is 1, so they have the same degree. And so I'm just going to rewrite this so that my Numerator is really in standard form, which means our highest degree term is written first, because we want to pick out our leading coefficients. Since our degrees, like I said, were both the same, they're both equal to 1, our leading coefficients to help us with the horizontal asymptote would be 20 over 1. So it'd be the horizontal asymptote is at y equals 20 over 1, which is just 20. And what this represents is that the average cost per person is going to approach $20. So the more people that come to prom, the more your cost is going to come down and get closer and closer to $20. But it would never be less than $20 because you've got to pay at least that per person for food. So let's write that out. The horizontal asymptote represents that the cost per person for prom will not equal 20, but it will get closer and closer as the number of people increases. Because you're dividing up the $1,200 you had to pay for the venue. So let's just finish that off with one more word. Okay, so the horizontal asymptote represents that the cost per person for prom will not equal 20, but it will get closer and closer as the number of people increases. Because you've got to pay at least $20 per person for food, and then you've also got to pay for the venue. So it's never going to actually equal 20, but it'll just get smaller and smaller as it approaches 20, the more and more people that are invited to prom. Now let's just take a minute and type that in Desmos and take a look, because you can see some things with your table of values for what I'm talking about. So if I type in the function that I wrote, I don't have to put y equals or f of x equals, but you can if you want to. I can just start typing my function. So 1200x plus 20, or excuse me, I don't need the x on the 1200. Let me start over. I'm gonna put this in parentheses. So 2x, I can't talk, 20x plus 1200 divided by x is my function. And you can put y equals if you like to do that, or f of x is fine, either one. And then we look and see, and you can check and make sure you have the right idea. Like x equals 0 was our vertical asymptote. So I can tell that that does line up with my vertical asymptote on the graph. And then y equals 20 should look like it does line up with the horizontal asymptote on the graph. But now if you look at your table of values, it'll verify some things that I've mentioned. Like as the number of people increases, so like as x increases, so let's say 50 people were coming to prom. So notice your cost per person is $44. But as that increases, so say 100 people come to prom, notice now the cost per person is now down to $32 per person. And if like 200 people came to prom, I get 26. But let's say I get 1,000 people to come to prom. Notice it's getting closer and closer to 20, but no matter what number you put, it should never equal 20 because you've got to divide up the 1,200. So it's always going to be at least some fraction of that number included. Okay, so with Desmos out, let's look at number 5. We need to compare some key features of the graphs of these two functions we were given. So let's clear everything out, reset our window, and I'm going to type just the function. You don't have to type f of x or g of x, but you do want to keep track of which one's which. So I like to try to keep track of which one shows up with which color on my screen. So this one is in red on my screen. And then the next one, let's see what color pops up. So the first one's red and the second one was blue. That way I don't lose track of which one's which. And it says, which function has an end behavior of as x approaches negative infinity, y approaches negative 5. So as x is headed toward negative infinity, that means that's where the graph is going off to the left. So if I look over here on the left of my graph, I see the red one, the y value is approaching 0, but the blue one is approaching negative 5. And the blue one is g of x, so that would be that one. And then it says, which function has a horizontal shift to the right from the parent function? So I can look at this right here and see that this does shift to the right because it's in the grouping symbol and it's -2, so it goes to the right. But you can also look at the graph and see that the blue one has shifted to the right. Your parent function is just the basic rational function of 1 over x. Let me see if I can make it show up like, let's see. There you go. I'm gonna make it look more dashed. So that's not really the one we're looking at right now. But from the parent function, I can see the blue one went to the right, the red one went to the left. And so the blue one was still g of x. So that was still the one I would choose for that part. Then it says, which function has a discontinuity in the form of a hole in the graph and where is it located? So the best way to do that is to try to factor out your function. So the red one looks like it could use some factoring. So I'm going to write out f of x in factored form and see if there's a hole in the graph, because that would be my first thought. We know holes occur where our factors cancel out. So I've got to do the MA chart and see what will multiply to give me -6 and also add up to give me -1. And that would be -3 and 2. So I get x minus 3, x plus 2 for my factors of the denominator. And then I notice I do have a hole because x minus 3 would cancel out. There should be a hole at x equals 3. And then we could just check and make sure that's true with the red graph. So I'm just going to turn off the parent function and turn off the blue one. And if it's a hole at 3, I can use my mouse to go over and check on that. And it does, in fact, look like there's a hole at 3. And you can also check your table for that function. So if I type in 3, it says undefined. And then all the work you need to support your answer is the factored form. So just make sure to show that part because that shows where this factor cancels out. So I'm going to make a note. And you don't have to write this on your quiz, but this is where the hole occurs. So where the factor cancels out, a hole occurs where those factors would equal 0 because that's what's restricted. And I wanted to mention one other thing about number 4. On your actual quiz, I will only ask you about the vertical or the horizontal. But I wanted to show you on the practice quiz both because I'll just pick one or the other to ask about on the actual quiz just so that we have enough time to complete the quiz in our 20 minutes. All right, so that is everything for practice quiz number 12.